Yeah. So, as I told you, thermochemical equations, what are they? They are the equations where delta H is actually denoted and we give the physical states. This is how it will be. Is that clear? So if I put that delta H naught F, whatever value I give, that will become the enthalpy of formation. Is that clear? So can you tell me what is this? What is the alternate way I can give this? Is it not formation of carbon disulfide from its elements? Just see. So can I call this as enthalpy of formation of CS2? Right. What reaction? We are referring to formation, isn't it? So in other words, I can call this as enthalpy of formation and its value will be plus 128. What is it? What does that plus 128 mean?
Energy is absorbed.
Exactly, it's endothermic. This is something that you should be in a position to deduce from the equations, from the notations, all this. See, symbolically, something will be given. Symbolically, data will be given. You should be in a position to deduce all the information just by looking at the symbol. Okay. So tomorrow, none of this equation will be given to you. It is given delta H naught F is just plus 128.5. You have to write the equation. So how will you write it? The equation is this. Is that clear? Next. Once. So let me take up the enthalpies of phase changes. I told you, right? It's not necessary that it should be a chemical reaction. Even in physical changes, the enthalpy changes will do occur. There will be heat absorption and heat evolution. So enthalpy of fusion. Be very careful. For fusion, we don't write F because already formation is there. This is fusion. We write it as delta H, not F. So what is fusion? Fusion refers to, it is actually conversion of a substance from solid state to liquid state. So from solid to liquid, if I, what is another name we give for melting? Melting has got another name. Do you know that? What happens during melting? Solid converts to liquid. Right? Now, this is also known as fusion. That's another name. So sometimes we use the word fused NaCl. What do you mean by fused NaCl? NaCl has been fused. So that means NaCl is in liquid state. Please try to get the meaning from this. Okay. Once you miss this, word fused and, you only take up NaCl, you will put NaCl in solid state. Fused NaCl indicates that NaCl has been melted and you're getting NaCl in a liquid state. So fusion means melting. So when solid is converted to liquid, is it absorbed or heat is absorbed or evolved?
Evolved.
Okay. Do you heat a solid to get a liquid or what do you do? When you have to heat, yeah, it is. So what type of change is solid to liquid conversion? Is it exothermic or endothermic?
Endothermic.
So what shall be delta H naught fusion for melting? Positive or negative? It will be positive. When I take a liquid to solid conversion, reverse, the value will not change. Just, it's reversed. So the sign convention will be changed. In other words, the same amount of heat, whatever is utilized for converting solid to liquid will be, released when liquid is converted back to solid. So this is going to be exothermic. So what is happening? So another important distinction you have to make when a reaction is when you're reversing an equation, delta H value will remain same, the magnitude remains the same, but the sign changes. That's it. That is something you have to keep in mind. reversal of equation reverses the sign. Got it? Nothing will change. The value also will not change. Suppose I call this, something I say that it's plus 198 kilojoules per mole. I'm just giving you random. So what will be the same in the reverse? It will be minus 198 kilojoules. Is that clear? From the sign, you have to do. You have to analyze whether it's melting or freezing. Yes. Next is enthalpy of vaporization. Again, see, we are using the word vaporization. The opposite of vaporization is condensation. We don't use the word enthalpy of condensation in this case. But the name is called as enthalpy of vaporization. So as we say vaporization, what is the conversion there? Come on. What will vaporize? When I say vaporize normally, liquid will convert to?
Gas.
Gas, isn't it? So this is, so 1 mole of a liquid is converted to 1 mole of a, see, everything is per mole, students. That's something that you have to keep in mind. Because I've been emphasizing on the conversion, but keep this in mind in the background. Everywhere we are taking 1 mole. Whenever you're, defining this, it's 1 mole of solid to 1 mole of interconversion of 1 mole of solid to liquid. The first case. The second case, interconversion of 1 mole of liquid to gas. So if liquid is converted to gas, this enthalpy of, we call it as a vaporization, this will be what, positive or negative? Liquid is converted. You're boiling water. Do you supply heat or heat is given out? As simple as that.
Positive.
Yeah, so always liquid to gas conversion is endothermic. And gas to liquid, the process is actually condensation. So how do you know that a condensation has occurred? Because your delta H is negative. We will not call it as enthalpy of condensation. Okay. So we say enthalpy of vaporization is negative, implies condensation. Okay. Enthalpy of vaporization is positive, implies the vaporization of liquid to gas. Got the meaning there? So a lot of meaning is hidden in these terms. You have to, be thorough with those meanings, the notations and the equations you write. So designing equation is an important exercise in this part of thermochemistry. Yeah, next comes the calculations. Okay. Next. Enthalpy of sublimation. See now, sublimation. It's again 1 mole. What do you mean by sublimation?
Solid to gas.
Yeah. So when solid is converted to gas, this will be positive. And when gas is converted to solid, this will be negative. The same amount of energy will be released. What do you call the reverse of sublimation? Okay, this is an open question to you. Okay, think about it.
Deposition, right, ma'am?
Yes, sir. Deposition is also correct. And even sometimes we say sublimation. That's also correct. Both are called a sublimation.
Okay.
Can be referred both the ways. See, yes, again, now how will you know which sublimation it is? If you ask me a question, if delta H is positive, then solid is converted to gas. And if it's negative, gas is converted to solid. Okay? That's how we can interpret it. Yes. Other equations? Enthalpies of
we also
different.
call it as desublimation. Sometimes.
I don't know, sir. See, if you take a patent and say that you're a patent holder, I will call it as deep sublimation. You have been approved, we can call it. That's what I tell. Some students keep asking me, can I call this? Can I call that? You become a patent holder. Tomorrow onwards, I'll start calling it. Yeah. Okay, before I go to enthalpy of atomization, I would use the other terms. Enthalpy of combustion. 1 second, students. Because I want to go uh, yeah, enthalpy of a reaction. So this is actually enthalpy of a reaction is given as sum of enthalpies of formation of products minus sum of enthalpies of formation of reactants. See, suppose I have an equation. CH4 plus 2O2 is giving CO2 plus 2H2O. I'll call this liquid, gas, and then also gas. Okay, this is a reaction, right? So if I have to form the enthalpy of this reaction, what is it? It will be sum of enthalpies of formation of products. So it will be enthalpy of formation of CO2. See the products? Plus, there are 2 moles of water. So 2 times enthalpy of formation of water. So this will be your products. Minus reactants. Enthalpy of formation of CH4 plus 2 times enthalpy of formation of oxygen. Is it clear? So you can always find the enthalpy of the reaction this way. Formation of products minus formation of reactants. And one important thing to be noted here, delta H naught F for elements is always 0. How is O2 formed? I ask you. See, when I say formation, what is the meaning? It is from its constituent elements. Now, O2 is already an element. So, what is constituting? Is there any other element constituting an element? No. Elements constitute combine to form a compound. But what is an element made up of? Right? So, they are made up of atoms, you may say. It can be molecular state or atomic state. So, what is the most stable state that it's coming from? Nothing. So, enthalpy of formation of elements is always 0. So, whenever you come across enthalpy of formation of, sodium or enthalpy of formation of carbon or enthalpy of formation of hydrogen, anything like this, it's all 0. Blindly you can go, it's 0. Nobody will give you the value. Please let me tell you. Nobody will provide this value in the exam. Why? Because it's going by your basic concept that enthalpy of formation of elements is 0. So in this case, which is the element in this equation? What is the equation we have? Which one is an element in this equation?
Carbon.
No. Do you have... No, in the equation. In the equation we designed now, which is the element?
Oxygen.
Yeah. So when I say minus delta H methane plus 2 times the enthalpy of formation of oxygen, O2 will be having a value 0 now. So you're left out only with methane in the reactant side. Are you getting it? That is something that you have to remember, use it. Nobody will give you the value that it's 0. That's something you have to keep in mind. Okay. I gave you enthalpy of formation of NaCl now. Right? Did we not create an equation like this? Yeah. So what will be enthalpy of the reaction? In this case, enthalpy of formation of NaCl product. Do you get that? Minus enthalpy of formation of Na plus half times enthalpy of formation of Cl. Am I right? Are you able to get this? Now, enthalpies can be measured using calorimeter. You must have done this in physics. Measurement of heat. Do you remember doing measurement of heat using calorimeter? If not, definitely you would do. You would have the experiment even in the practicals also, because calorimetric calculations and all is common in physics practicals. You have a calorimeter, you will find the enthalpy, specific heat measurements, everything is done in calorimeter only. Is that clear? So you measure it in calorimeter. That's a device, that's an instrument used to measure the heat. So experimentally, you'll be able to find the delta H there. So enthalpy of the reaction can be measured. Is that clear? Now, just observe this. What is this enthalpy of the reaction? Is it not sodium is 0 and chlorine is 0? So whatever calorimetric measurement is coming up, that shall be your enthalpy of formation of NaCl. Did you understand? Because sodium and chlorine will be 0 according to your definition of delta H reaction. So enthalpy that is happening, the change in enthalpy, whatever calorimetric measure you get, that will be a delta H, which will be nothing but equal to enthalpy of formation of NaCl. Understand? So this is how the enthalpies are calculated. And for delta U, I will tell you later. You also can learn it. It's called as a bomb calorimeter. For measurement of internal energy, you use bomb calorimeter. So the working of bomb calorimeter, everything is there, delta U measurements. This is what we use, a bomb calorimeter. The working of this, you will learn it. Okay. I'm not going to highlight much about this. Application is more important for us. Same thing, ordinary calorimeter will be like this. You must have had, no? If you have ever seen a copper vessel or something, they will have, there is a wooden box inside that, there will be a copper vessel, the stirrer, everything. This kind of arrangement will be there. It will be there in physics labs. So they do it, sir. The practicals. Yes. So other reactions we have is, see, enthalpy of atomization. This is something that I have to, mark it very, very, very important. You use this exactly the same terms, the same application in class 12. Okay. Atomization. It is, we call it as formation of one, it's formation of gaseous atoms. Actually, that's the meaning. Formation of gaseous atoms from 1 mole of a substance. Keep this in mind for atomization. So, how the 1 mole of, how gaseous atoms are, formed from 1 mole may change from substance to substance. Is that clear? So, see, look at this. Hydrogen is broken down to hydrogen gaseous atoms. So, 1 mole of hydrogen is broken down to 1 mole of, 2 moles of gaseous atoms. So, we call this as enthalpy of atomization. Now, if you see from a different context, hydrogen is breaking means what? Isn't it HH bond is actually breaking? Only then it will give hydrogen gaseous atoms. So, from a different context, what is this enthalpy of atomization of hydrogen? It's nothing but it's a bond dissociation enthalpy. It's the energy required to break 1 mole of bonds of H. Is that clear? So, depending on the context, your definition changes. But here, in terms of atomization, I'll call it enthalpy of atomization. In terms of enthalpy, I'll call it as bond dissociation enthalpy of H2. Same thing works. If I call it chlorine is giving 2 chlorine atoms. What will I call this? This is enthalpy of atomization of chlorine, or I can say enthalpy of dissociation of chlorine. Both are one and the same. It is the same, only context is different. See, otherwise, sodium solid is converted to sodium gas. What do you call solid? Just now we did. Solid to gas conversion? Sublimation. Isn't it? Where from the definition of atomization, that's why I want you to view it this way. Please. Formation of gaseous atoms from 1 mole of substance. View it this way. It will be appropriate. You will be able to use it in, the different equations you're creating. So, 1 mole of sodium is converted to sodium gas. It's forming gaseous atom. So, absolutely fitting with our definition. From the other angle, what is this? It's also sublimation. In other words, enthalpy of atomization of sodium is equal to enthalpy of sublimation. Is that clear? Suppose I call it as mercury liquid is converted to mercury gas. What will I call it? What is the delta H for this can be represented as?
Vapor.
I can call this as vaporization. Very well, liquid to gas. From the context of atomization, is it not also enthalpy of atomization of mercury? Because 1 mole of mercury is giving gaseous atom. Understood? So, based on the definition, you should be in a position to create the equations. So, you should be creators of equations here. As far as the thermochemistry part is concerned, you should be in a position to design the equation. Keep this in mind. Only then you will master this. Okay, if you're not thorough with the definition, not thorough with the interpretations.